Python is slow. This is not a revelation. Lots of dynamic languages are. In fact, Python is so slow that many authors of performance-critical Python packages have turned to another language, C. But C is not fun, and C has enough footguns to cripple a centipede. Introducing Rust. Rust is a memory-efficient language with no runtime or garbage collector. It's incredibly fast, super reliable, and has a great community around it. Oh, and it's also super easy to embed into your Python code thanks to excellent tools like PyO3 and Maturin. Sound exciting? Because I'm about to show you how to create a Python package in Rust step by step. And if you don't know any Rust, don't worry. We're not going to be doing anything too crazy, so you should still be able to follow along. Are you ready? Let's oxidize this snake. Before we get started, you're going to need to install Rust on your machine. You can do that by heading to rustup.rs and following the instructions there. I would also recommend creating a virtual environment that you can use for testing your Rust package. Here's a script that, given a number n, will calculate the nth Fibonacci number 100 times and time how long it takes to do so. This is a very naive, totally unoptimized function, and there are plenty of ways to make this faster using Python alone, but I'm not going to be going into those today. Instead, we're going to take this code and use it to create a Python package in Rust. The first step is to install Maturin, which is a build system for building and publishing Rust crates as Python packages. Next, we'll create a directory for our package, which we'll call fibrs. On second thoughts, let's call it fibbers, cause fibber's gonna fib, right? The final setup step is to run Maturin init and select the bindings we want to use. In our case, this is going to be PyO3. Now, if we take a look at our fibbers directory, you'll see a few files. Maturin has created some config files for us, namely a cargo.toml and pyproject.toml. However, since we're not going to be publishing our package, I won't go into those now, but you can also see that Maturin has created a GitHub Actions workflow for releasing our package for us, if we do want to do that. It's a small thing, but it makes life so much easier when you're maintaining an open source project. The file we mostly care about though is the lib.rs file in the source directory. Maturin has already created the scaffold of a Python module for us using the PyO3 bindings we mentioned earlier. The main parts of this code are the sumAsString function, which is marked with the PyFunction attribute, and this fibbers function, which represents our Python module. All this code is really doing is registering our sumAsString function with our fibbers module. If we installed this now, we'd be able to call fibbers.sumAsString from Python, and it would all work as expected, returning the sum of two numbers as a string. However, what I'm going to do first is replace the sumAsString function with our fib function. This has exactly the same implementation as the Python we wrote earlier. It takes in a positive unsigned integer n and returns the nth Fibonacci number. Now, we can simply register this function with our fibbers module, and we're good to go. To install our fibbers package, all we have to do is run maturin develop in our terminal. This will download and compile our Rust package and install it into our virtual environment. Next, back in our fib.py file, we can import fibbers, print out the result of fibbers.fib, and then add a timeit case for our Rust implementation. If we run this now for the 10th Fibonacci number, you can see that our Rust function is about 10 times faster than Python, despite the fact we're using an identical implementation. If we run it for the 20th and 30th Fibonacci numbers, we can see that Rust gets up to being about 30 times faster than Python. But what if I told you we're not even at maximum speed? You see, by default, Maturin Develop will build the dev version of your Rust crate, which will forego many optimizations to reduce compile time, meaning the program isn't running as fast as it could be. If we cd back into our fibbers directory and run Maturin Develop again, but this time with the release flag, we'll get the optimized production-ready version of our binary. If we now benchmark our 30th fib number, we see that Rust now gives us a whopping 90 times speed improvement over Python. However, we do have a problem with our Rust implementation. If we try and get the 50th Fibonacci number using fibbers.fib, you'll see that we actually hit an overflow error. This is because, unlike Python, Rust has fixed size integers, and a 32-bit integer isn't large enough to hold our 50th Fibonacci number, which, for those interested, is 12,586,269,025. We can get around this by changing the type in our Rust function from U32 to U64, but that will use more memory and might not be supported on every machine. We could also solve it by using a crate like numbigin, but that's outside of the scope of this video. Another small limitation is that there's some overhead to using the PyO3 bindings. You can see that here, where I'm just getting the first Fibonacci number, and Python is actually faster than Rust thanks to this overhead. I hope you found this video helpful, and that it's encouraged encourage you to try rewriting performance-critical parts of your Python code in Rust. Be wary that while Rust can speed up a lot of things, it won't provide much advantage if most of your CPU cycles are spent on syscalls or network I/O, as those slowdowns are outside the scope of your programming language. If you'd like to see more complete examples of Python packages written in Rust, the ones on screen now will be linked in the description. And if you like optimizing things to the fullest, check out this video on how a good understanding of SQL can speed up your Python programs by hundreds of times.